I want to take a few minutes to look at some prisms and their nets to help us develop what the lateral area and surface area of prisms and pyramids and cylinders and cones will be. So here is a hexagonal prism, and what we're going to notice here is if we open this thing up and look at the net of it. Remember, the net is the two-dimensional shape that can wrap around the three-dimensional shape. And what we notice here is this large rectangle here would be the lateral area. That would be the area along the sides, all the lateral faces together. And then we have the two bases. So to find the lateral area of this, we would want to find the area of this rectangle. Well, the area of the rectangle is simply, if you take a look at the height as this thing unwraps, the height times the perimeter, because all these sides are going to be together. They're going to form the top or the base of the rectangle. So we notice that the area of this rectangle is base times height, and the base is going to be the base of the, or the perimeter of the base of the prism, and the height of the rectangle is the height of the prism. So here it is written out for you. We have the lateral area and surface area of a prism, and I have the actual prism here along with its net, and that's to remind us that the lateral area of a prism is the base of a rectangle. So this base right here, so lateral area is really just this rectangle, which we mentioned already. And so the lateral area is the base of this rectangle times the height of this rectangle, and then referring those measurements back to our three-dimensional figure, that's going to be the perimeter of the base times the height of the prism. And so here it is in words. Here it is just in letters. Lateral area equals perimeter of the base times the height. And then the surface area is going to be that lateral area. So surface area of a prism is the lateral area of the prism, so that rectangle there, which is perimeter times height, plus 2 times the area of the base, because there's a base here and a base here. Now this one is a hexagonal prism. This will work the same way for a rectangle or for a triangular prism or a trapezoidal prism, whatever the case might be. So when we have this capital B here, this means area of the base, and that could take on a lot of different formulas depending on what that base is. Here we're going to do the same thing with the cylinder. So we have a cylinder here. We have the base is a circle. We have a certain height. In this one, we can actually change the height if we want to. We'll leave it about right here so we can look at this. And what we're going to do is we're going to open this up and look at the net. So there's one base, and there is, let's take a look at this. So we have, they're trying to show something here. Once again, to find the lateral area, it would be this red part right here. And the red part is a rectangle, so it's going to be base times height. But the base, as this thing unwraps, you'll see the base is actually the circumference of the circle. So the area of the lateral area will be the circumference of the circle times the height of the prism. And then to get the surface area of this, which I did not mention for the hexagonal prism, but to get the total surface area, you would add your lateral area plus the area of both bases. And in this case, the base is a circle, and so it would be pi r squared. As we look at the area, the lateral area and surface area of a cylinder, we're going to see that it's really the same idea as the lateral area and surface area of a prism, except that now, well, let's go to the similarities. It's the base of a rectangle. So here's our cylinder. Here is the net. The lateral area is this reddish pinkish part, and that's a rectangle. So the lateral area is going to be the base of a rectangle times the height of a rectangle. But what are those things in reference to our original figure? Well, the base is simply the circumference, and then the height is the height of the cylinder. So notice here I have it, circumference is 2 pi r, and then times h is the height of the cylinder. And then for the total surface area, you're going to take that lateral area, so the lateral area, plus 2 times the area of the base. Well, in this case, the base is a circle, so 2 times pi r squared. Again, here it is in words, and then here it is in those variables. Next, we have the lateral area and surface area of a pyramid. We want to go through a specific idea here first. So we're going to look at this pyramid right here, and we need to get some terms here. When we talk about the height of a pyramid, it goes from the vertex down to the center, or really just perpendicular to the base of the prism. So that's what we normally refer to as H, just the letter H. But what we're going to work with when we talk about lateral area is we're going to look at this lateral height, and we use a cursive L, a cursive lowercase l, and that's what this represents here and here. That's going to refer to the slant height. So the slant height of a pyramid is different than the actual height of the pyramid. Notice that the slant height will be longer than the actual height. So let's take a look at this. We're now going to look at our figures down here. Here we have, in this case, a square pyramid. It doesn't have to be square. It could be a hexagonal pyramid or an octagonal pyramid, but in this case, it's a square pyramid. And it does, for what we're doing, these are regular polygons on the bottom, so a square or a regular octagon, kind of like a stop sign or whatever it might be. So this is spread out. It still has the shape of the pyramid here with the net, and then here's the net flipped over. We see these dashed lines here. These dotted lines represent the slant height, and then we have the square here. And so to find the lateral area is just simply these, in this case, 4 triangles. If it was an octagon, it would be 8 triangles. So the lateral area is going to be the area of a triangle times the number of triangles there are. So the lateral area of a pyramid is 1/2 the base. So 1/2, remember it's 1/2 base times height, so 1/2 the base of a triangle. So there's the base, times the height. So that's the height of the triangle, and then times the number of triangles. Well, the base of a triangle is this red here. In fact, we can go ahead and base of the triangle, that's the red part, the side length. So that's the side length of a square, times the height of the triangle. Well, the height of the triangle in this case, the height of the triangle is the slant height. So there's the height of the triangle, that's the slant height. And then finally the number of triangles. Well, I put these both in red because if you take the length of a side, so this red, times the number of triangles, so the length of this side times 4 actually gives us the perimeter. So the lateral area of a pyramid turns out to be 1/2 the perimeter of the base times the slant height. So there it is in words. Here it is in variables. Lateral area equals 1/2 the perimeter of the base times the slant height, remembering that L means slant height. And then the surface area of a pyramid is really easy once you have that. It's just going to be your lateral area. And instead of being 2 times the area of the base like when we had cylinders and prisms, you're just multiplying it times the area of the base because there is only one base. You're adding, I think I said that wrong, you're adding the area of the base. So surface area equals lateral area plus the base. And again, this base could be a square, it could be a regular triangle, a hexagon, an octagon. So it could be all types of different bases. The last lateral area and surface area we're going to look at is a cone. And this one's a little bit different in that it's not as easy to draw and figure out, but what we can do is we can remember back when we thought of area of a circle, the closer we got to a circle, like we started with a regular triangle, and then a square, and then a regular pentagon, a regular hexagon, regular octagon, and they get closer and closer to looking like a circle. And so this actually is similar to what we did with a prism compared to a cone. It's going to be the same idea, except now we're dealing with a circle. So the lateral area of a cone is 1/2 the perimeter of the base, which in this case is a circle, so it's the circumference, times the slant height. So we still call this slant height, and it is even compared to the actual height there. So the slant height, which again we call L, so lateral area is 1/2 the circumference of the base times the slant height, and the surface area is simply going to be the lateral area plus the area of the base. That's the same as what it was for a pyramid, but in this case we know it's a circle, so we can say lateral area plus the area of a circle. So lateral area plus the area of a circle, which is pi r squared.